you just joining us since this is your first time here, the current program we're working on that we started on Monday, we just got barely started on it. So if you're just joining us, don't worry about it. It's pretty easy to catch up. And we're also working on it in the lab. Is this fox and rabbit game where basically we've got a fox chasing the rabbit and you've got to program the rabbit, okay? And right now we're going to look at the fox's algorithm for chasing the rabbit down and giving it a nice teeth-filled hug, let's go ahead and say. So the fox, right, so remember the rabbit's strategy is kind of bleh. It just has a constructor and then it decides its move at random, which has very poor outcomes for its survivability. The fox, on the other hand, has a simple strategy. Now, also, strategies don't need to be too complicated. I just saw somebody score a 94 on this, so it had a 90% survival rate by having a very simple strategy. Okay, it was very, very simple. Okay, so the fox extends. So the fox is an animal, and it just keeps track of have seen rabbit now equals false. Can I see the rabbit now? So basically, it keeps track of these things. Why does it have to keep track of these as instance variables? It's because we keep calling every term we're going to call the decide move method, right? So if it wants to have any memory, we need to keep that memory as instance variables. Okay, the distance to the rabbit, the direction to the rabbit, and the current direction I'm going. So it keeps track of like what direction it wants to be traveling in. Okay, so the fox, its constructor, the only difference is that it initializes current direction as a random direction. So the fox is going to start moving. It's going to start moving in a random direction. Okay, so let's take a look at the actual decide move function. Okay, so the first thing it does is that it looks around for the rabbit. Okay, that's the first thing it needs to do to make its decision. Because obviously, if it can see the rabbit, then I probably want to get close to it so I can eat it. So it says, can I see the rabbit now to false? Can I see the rabbit now? And then it looks at all the directions. So it goes from model min direction to, and remember, and again, this is just something wonky I do with my fonts. It's with ligatures. So less than or equal to becomes the actual less than or equal to sign. I is less than or equal to model.max direction, I++. So it looks at it looks in every direction, and it goes, okay, and I added the this keyword, right? Because to emphasize that this is something it inherits from an animal. It looks in that direction, and if it looks and sees a rabbit, it says, oh, I've seen the rabbit, and I can see it now. I set the direction to the rabbit to that direction, and I set the distance to the rabbit equal to the result of the distance function. Right, you can use distance I to get you the distance to the nearest thing at the direction, be it a bush, the edge of the board, or another animal. Okay? So now its strategy is, if I've seen the rabbit recently, not necessarily this time, right? If I've seen the rabbit this time, that's can see rabbit now. But if I've just seen it recently, right, I know I've seen it and that I probably want to get close to it, then I'm going to try to move towards its last known position. So this is actually a very important insight about the fox. If it sees you, it's going to try to go to where you were, okay? Assuming you run away. Okay, so if I have seen the rabbit, and my distance to where to the rabbit is greater than or equal to 0, I'm going to decrement my distance, right? And then say I move closer to the rabbit, right? I go in the direction towards the rabbit. Okay, otherwise, if my distance is equal to 0, right, if it's not greater than 0, it's equal to 0, you can't have a negative distance in this instance. Well, I saw the rabbit, I got to his last known location, and now I can't see him, right? And I'll get up there on the board in a bit to demonstrate that in a bit more detail. Where did it go? Have seen rabbit is equal to false, and I set the current direction equal to choosing a random direction. So if I can't see the rabbit, then it just starts looking around at random. Okay? And if I haven't seen the rabbit, or I lost track of the rabbit like I did in this else case, I continue going in the current direction. Maybe I have to dodge some bushes in order to find the rabbit. Okay? So what I do is that if I can move in, so maybe I have to go around a bush, and this is the way it does that. If I can move in the current direction, right, so can move, that's a Boolean that returns true or false. That's something I can call from the animal class. If I can go in the current direction, awesome, I do so. Otherwise, what do? I ask, can I move current direction 1? And that's being passed to model.turn. So remember, the way that model.turn works is essentially that if is that the second parameter is how many 45-degree turns you're making, right? So current direction 1 means one 45-degree turn. So this direction so if this is the direction I'm going, current direction M1 would give me this direction. Current direction M2 would give me this direction. Current direction M4 gives me the opposite direction, which is useful if you want to run directly away. Okay? Current direction and you can also pass it -1 to go counterclockwise. So basically you say, okay, if I want to go this way, if I can't go this way, I'm going to try to sidestep and go diagonally. If I can't do that, it says, I'm going to try to go this way. And if I can't do that, according to this one, it chooses a direction at random. And then it just chooses a direction at random, and then it says, okay, can I move in this direction? No. Can I move in this direction? No. Can I move in this direction? Yes. Now that's my new direction. So it essentially chooses a new random direction if it bumps into a wall. If it can't keep moving forward, then just chooses a random direction and wanders in that random direction instead. And if for some reason it gets stuck somewhere, which really doesn't happen, it just doesn't move. That's the Fox's code. Now, how can we exploit this? It's less about, so there's 2 things you can exploit about the Fox. Okay? And all the strategies I see with a high level of success use these facts. Okay? So give me 1 second to just confirm that I've set this so that I'm now capturing purely from the web camera. And let's go ahead and turn this guy around. Yeah. So hope you don't mind being caught on the camera, by the way. Everybody okay with that? Okay. So, all right. So we've got so let's say this is the Fox over here, and I guess you put him in a grid of sorts, right? A fairly rough grid. Right, I'm not going to bother drawing above the box, just simply because it will be symmetric. Okay, right, let's take a look at his line of sight, okay? The Fox's line of sight is represented by these dots over here, right? So extend dots out this direction. Okay, also down, okay? And also diagonal, which leads to some interesting observations, right, as to where we can put a rabbit and not be seen, okay? Right? Obviously, if I'm directly in the line of sight like this, I can be seen. Okay? Well, and we'll return to that. But interestingly enough, if I'm right here, it can't see me. Interesting enough, right? The Fox won't see me there. Okay? Now, however, if the Fox does see me like right over here, I've got options as to where to move now, right? If I move essentially south away from this Fox, I'm not really changing anything. I'm just other than like the relative orientation of bushes around me, right? The spacing between me and the Fox won't change because if I move south, he's going to move south. If I move south, he's going to move south, and so on and so forth. However, if I move over here, the Fox is going to move south, okay? And let's see what happens there. So the Fox moves south. Let me go ahead and erase these dots over here because it's going to change now. Fox moves south, and it looks, and I'm in this blind spot. Can't see me. Now we know what is its next move going to be, though. So I'm going to move wherever I want now because it's my turn again. And I can move, let's say I move here now, okay, down to the right. What's its next move going to be? It's going to keep going south because it's headed to my last known position, right? Or I could have headed some other way. But the point is that it heads to where it last saw me. So I can exploit its blind spots essentially. most of the round, right? You need 100 turns to survive. So that's most of that there, and give or take about 20 for the fox to actually find you, so that's a win. So that's one strategy. The other strategy is just actively hiding, like exploiting the blind spots and just making sure you can step out of the blind spot, and then when the fox sees you, you head away in a direction. It's just solving the puzzle and heading away from him in an intelligent manner. Okay, not so you can either lead him on a chase or you can try to escape him, or you can do either. Right? If he gets really close to you, you're gonna have to lead him. Like for instance, if I'm here, okay, I pretty much there's a couple options I can take. There's a couple moves I can take. There's definite moves not to take, like going here and here, okay, because then it will eat me, okay. But there's options I can take. On the other hand, if we're right next to each other, basically we are in an end game, and I'm just trying to survive getting cornered as long as possible, okay. So this isn't necessary until you're like really trying to rack up your points, like above an 80 or 90 range, which is taking into account basically how many spaces away the fox is from you, and then taking advantage of that. At least from the strategies I've seen. Okay. So there's a good number. Okay. So what should you be doing now at this point then? For right now, what you need to be doing, the first thing is something stupid that's not going to give you many points, just simply so you can get it working, which is look all around you. If you see the fox, move in the opposite direction. Once you get that, you at least know that you can control the rabbit. That's not a very good strategy, but at least at that point you know you can control it. I saw a lot of students that what they do is that they try to copy the fox code without necessarily understanding it. If you do copy the fox code, delete the parts you don't want, because the fox code is designed to chase things. So if you don't take that into account, right, and you just use it as is, essentially what you're going to be doing is you're just directing your rabbit to give the fox a nice big furry hug, and that's not going to end very well for you, right? So what you need to do is use the fox code for an example of how to do things, not necessarily what to do, right? How to do it, not necessarily what to do, because it wants to keep you in line of sight. It wants to chase you down. It wants to go where you ask for it. That's what the fox wants to do in order to find you. You want to break line. You want to break line inside. You want to get away from it. You want to hide from it. Or depending on if you're using the kite strategy, you want it to follow you in a controlled manner. Okay. So either of those strategies will work. Again, you have until like Tuesday evening to do this. So, and we should have a new assignment upcoming on Monday for you guys. So, and the labs are 2 hours long, so plenty more time to work on this. All right, so go ahead and get to work.